Welcome to lesson 4. We're going to jump into pyramids and cones. I'm only going to spend a little bit of time at the end on cones because cones and pyramids are essentially the same, just like prisms and cylinders were essentially the same. So a pyramid is different than a prism. A pyramid is a polyhedron where one face, the base, can be any polygon, and the other faces, the lateral faces, are triangles that meet at a common vertex. Okay. The altitude is a little different. I mean, kind of. The altitude is a little bit different. Is the perpendicular segment from the vertex to the plane containing the base, or the plane of the base. So you will have some pyramids that are kind of weird. So you got like a rectangle down here, and then this pyramid kind of goes off like that. It's kind of weird. The plane of the base extends on forever in all directions. The altitude is what's perpendicular to that. We're not going to be dealing with that very much, but just so you know, it's the plane of the base. Okay. Now there's also something called the slant height. This is new. This is not in prisms. The slant height is the height of one of the lateral faces. We use the cursive L to represent this measurement. You'll see it all the time. Okay. So altitude and slant height. We have seen altitude. We have not seen slant height. Altitude is going to seem a little different when I show you. Okay. So the net below represents a square pyramid. I'm going to draw as best I can the 3D shape. So this is a square tilted so that I can show you what's happening here. All right. So imagine I cut a hole right here at the top of the pyramid, and I dropped a line straight down to the bottom. That's the altitude. It is not on the net. The net is right here. It is not on the net. I cannot draw the altitude on the net. Okay. Imagine I'm back up there at the top of the pyramid and I slide down one of the triangles. Well, that distance that I slid was called the slant height. It's along the outside of the pyramid. That can be drawn on the net. That's the height of each of those triangles. So this is L. This is L. L and L. And this is a square at the bottom, which is B, 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 and B. Okay. We don't know what it is here, but it's going to lead us to the formula. So the lateral area is the area of the figure without the bases, or in this case, without the base. In other words, the lateral area of a pyramid is the area of the triangles only. Because the one base is a square, we're not including that, so it's just the 4 triangles. And how many of those triangles are there in this problem? There are 4. So in this pyramid, specifically, we could show the lateral area by 1/2 base times height, but the height we write as L, and then times that by 4. Let's go ahead and rearrange this. Now, some of you might say 1/2 of 4. I'll just say 2BL. Is that the formula? No, because not every pyramid has 4 triangles, so I can't do that. But what I can do is I can put the 4 with the B and then put the L at the end. Now, what does 4B represent? That the 4B represents the perimeter of the base. So this is P, and that's where the lateral area formula comes from. lateral area of a pyramid is 1/2 PL. I don't care if you have a three-sided, if you have a triangular pyramid. Okay, and that number there would then be a 3. I could put 3 with B, and 3 times B would give me the formula or the perimeter of the base. Okay, so it's always 1/2 PL. Okay, the surface area, we have to include the area of the base. That's all we have to do. There's one base. So the surface area is the lateral area plus 1 base. Or if you want to be more specific, 1/2 PL, which is the lateral area, plus big B. Again, like in prisms, I can't put anything for big B because the shape is going to change. All right, backside. Oops. The pyramid below is a square pyramid. Helpful information. The altitude is 24 centimeters in this one. The slant height is 26. And then I want you to notice that the altitude, the slant height, and half the base form a right triangle. You're going to use that right triangle to find altitude, slant height, other things in this problem. So I told you the bottom is base is a square, so this is also 20, which means that this is 10. You could also do the Pythagorean theorem to find that that's 10. Okay, so the lateral area here is 1/2 PL, where P is the perimeter of the base. Well, 20 plus 20 plus 20 plus 20 is 80. And the slant height is 26. It's given to us. 80 times 26 divided by 2 is 1,040 centimeters squared. What is the surface area? Well, it's the 1,040, the lateral area, plus the area of one base. Well, the area of the base is just a square, so it's just 20 times 20, which is 400. So 1,040 plus 400 would be 1,440 centimeters squared. And that is the surface area. And we'll do a couple more. Next one's pretty easy. And then number 2 is more challenging. Find the lateral area and surface area. So the lateral area is 1/2 PL. P, well, it looks like it's a square again, 6, 6, and then the other sides would be 6 and 6 as well. So that would be 6 times 4, so 24. Slant height, hopefully you catch it, is 5. So then I've got 1/2 24 times 5. One thing you have to remember is that 1/2. In prisms, you just didn't multiply the two numbers, didn't do the 1/2, but now you got to remember the 1/2. But that ends up being just 60 units squared. And then the surface area, I just have to add in there the base. The base is 6 times 6, or 36. So 60 plus 36 is 96 units squared. All right. Now we're going to take a big jump and go a lot harder. Okay, so the lateral area here, again, is 1/2 PL, where P is the perimeter of the base. Well, I don't have that. And I also don't have the L. I've got a regular hexagon. I've also got a right triangle. Does everybody see the right triangle there? That would be this triangle that I'm outlining. The altitude is 4, which is the leg here. The slant height is the hypotenuse, and then this is the square root of 3. So I'm going to do the Pythagorean theorem to figure out L. So the square root of 3 squared plus 4 squared equals L squared. So that's 3 plus 16 equals L squared. So 19, square root of 19 is the slant height. And I'm just going to leave that alone, square root of 19. Okay. Now, I've also got a regular hexagon. So I'm going to go way over here and draw. I know you know that I don't need to draw this, but for now, I'm going to do it to show you what we've got. I've got the apothem because it goes from the center and it's perpendicular to a side is radical 3. That angle there is 30. Hopefully don't have to explain that anymore. Meaning I've got the apothem is the long leg. Okay. And the short leg is divide by radical 3, right? So long leg is radical 3. And that's radical 3 times the short leg. Divide by radical 3. Well, I get the short leg is 1. So that's 1, which means this is 1, which means the side length is 2. 2 times 6, the perimeter is 12. Okay. So I've got my 1/2 perimeter is 12. And the slant height is 19. Square root of 19, sorry. Half of 12 is 6 radical 19. And that is my lateral area, meters squared. Now I've got to find the area of the actual regular hexagon. So I've got 6 radical 19 as my lateral area plus the base. Well, I've almost done the base. You didn't know it, but I almost have. So it's 1/2 AP. I'm going to go back over here. The apothem, we already said, was square root of 3. And the perimeter we already found as well. That was 12. Right? So I already have everything I need for the area. So it's 1/2, 12, and then radical 3. So it's 6 radical 3 is the area of the base. And that's, I can't put those together. 19 and 6 are different. So my radical, or my surface area is 6 radical 19 plus 6 radical 3 meters squared. Okay. Nasty numbers, but just showing you that it is still doable. Okay, cones. I'm going to spend the last 2 minutes talking about cones, and maybe a little bit more, 2.5. Okay, cones are treated the exact same as pyramids, except the base is a circle. And the lateral face is a sector of a circle. The formulas are almost the same. So again, the lateral area of a pyramid was 1/2 PL, where P was the perimeter of the base. Well, the perimeter of the base is being a circle would be 2 pi r times L. Well, what's half of 2? It's just 1. So what's left is pi RL. And there it is. The lateral area of a cone is pi RL. That's it. The surface area, almost as easy as just pi RL, the lateral area, plus the area of one base, and the base is a circle, so pi r squared. So let's do it. The lateral area and surface area. So lateral area is pi RL. So the radius is 5. The slant height I don't have. I have the altitude. 12 is the altitude, but I've got myself a right triangle there with 5 as the radius and 12 as the altitude. Pythagorean theorem to get the slant height. So 5 squared plus 12 squared equals L squared. Save us some time. That's 13. It ends up being a good number. So pi times 5 times 13 is 65 pi for the lateral area, and that's centimeters squared. And then the surface area just adds on to that. Pi r squared. So adds on to it 25 pi. 65 plus 25 is 90 pi centimeters squared. And that's it for cones and pyramids.